that went so far.
I wonder what its position vector was.
It looked like it was a parabola with the equation negative x squared minus 4x plus 4.
Wow, that's a nice parabola.
I know. I wonder how fast it was going at t equals 0.5 seconds.
If only we had a slow motion camera to figure that out.
But wait, there's another way to figure that out.
How?
Calculus! Welcome to the Calculus Castle. So just a little disclaimer, the parabola that we chose in no way reflects the example of the volleyball. A lot of the math deals with negative time and speeding up, like a particle that's speeding up when it's positive time, so yeah. But the math is alright, it just isn't really a volleyball. Alright, so we have our position vector right here, and we want to know how fast it's going at 0.5 seconds. So first you have to get your velocity equation. To do that, you take the derivative of the position using the exponent rule. So this is your velocity equation after taking the derivative of this. Next, we want to know what the velocity is at 0.5 seconds. So it's going to be v of 0.5, and then you just plug it in for x. After you simplify, you get -5. Don't forget your units.
But wait, Ariana, what was its acceleration when the velocity equals 0?
Let's find out. Alright, so we're trying to find when the velocity is 0, what's the acceleration? So first, we need the acceleration equation. To do that, you take the derivative of the velocity equation. In this case, it's just -2. So this means that at all points, acceleration is going to be -2. So just to prove this, we're going to find out when velocity equals 0, what's the acceleration. So we're going to set the velocity equation equal to 0. And we factor and find that velocity equals 0 at t equals -2 seconds. We then plug that into the acceleration equation, which, because there's no variable to plug into, it's -2.
Wait, how do we know when it was slowing down? I just hit it. It just went.
Well, let's use calculus to find out. Alright, so to find when it's speeding up or slowing down, you can graph both the velocity and acceleration equations, and then whenever they're on the same side of the x-axis, that's when it's speeding up. So in this case, from -2 to infinity, they're both below the x-axis, so it's speeding up then. And then from -infinity to -2, they're on opposite sides of the x-axis, so it is slowing down.
So if we found out all these things, can we find the total distance traveled?
We sure can!
To find the total distance on the interval -4 to 1, you have to find the 0 on the velocity, which is -2. Then you make a number line with the interval and the 0. Then you have to plug in the interval -4 into the position vector, which is 4. And then you have to do that for the 0, so it's -2, which is 8. Then you do the absolute value, which is 4. Then you have to do that for this time on the graph, which is -1 and 8, so then you add them together and get 13 feet.
Now that Ms. Compian's given all these tools for us to find out the answer to these questions, we can go back to playing volleyball.
Great!